Welcome to IQ Online Class. Thank you very much. We are back again. We need more contents on mathematics, so upload more content on mathematics from starting level 1 and level 2. Okay? So don't forget to subscribe and also turn on the notification button for more contents. Okay? So today we are looking at binomial series. Okay? So on this one, firstly, we will need to look at what we call binomial expression. So what is binomial expression? Okay, so this is an expression. This is an expression with two terms separated by either plus or minus sign, and it is raised to a certain power. Basically, that is binomial expression. So, for instance, when you have this expression, let's say I have a plus x raised to a certain power. This type of expression is what we call binomial. So in this case, bi means 2. So we have two terms here. A is what we call the first term, x is what we call the second term. So now these two terms here are separated by plus. So you can either have plus or minus according to the definition here. So now, most of the things which we look at here, one of the things which we look at here is expansion of general expansion of binomial expressions. Okay? So now, before we come to expansions, you need to know what we call a Pascal triangle. You need to know what we call a Pascal triangle. So this Pascal triangle helps us to find the coefficients of a certain power. So this Pascal triangle looks like this. So let's say you have this same expression here. So this a plus x raised to the power 0, okay? The coefficient which you get there is just 1. Remember, from the index point of it, anything raised to the power 0, the answer is 1. So when we raise this same expression, a plus x raised to a certain power there, here I'm not looking at the expansion, but we are basically looking at the coefficients. So the coefficients which you get will just be 1 here. Okay? So these are coefficients. So when the power is 0, the coefficient is 1. When the power is 1, these are the coefficients which you get 1. Okay? So when the power here is 2, okay, the coefficients which you get there will be 1. 1 plus 1 you get 2, then here 1. When the power is 3, the coefficients which you get, you have 1 plus 1, 3. 1 plus 2, 3. 2 plus 1, 3. 1 here. Okay? So basically you continue forming these coefficients. Let's maybe end at the 4th power there. So when the power is 4 here, the coefficients here you have 1. 1 plus 3 is 4. 3 plus 3, 6. 3 plus 1, 4. Then here what? 1. So basically these are the coefficients with respect to each power. Okay? So you need to know the Pascal triangle to do any general expansion of any binomial expression. So now, what we are going to do here is this. Okay? We'll make this simple. You don't need a binomial, rather a Pascal triangle to find the coefficients. So now we'll show you the easiest way of doing it. What do we do? For instance, we are taught to expand. Let's expand This is an example. This is an example. Expand. Okay, expand will be x plus y raised to the power 4. Okay, expand this binomial expansion. Okay, so now what you need to bear in mind is that when you have the power of 4, you expect it 5 terms. That's how it is. So for example here, 0 gives us 1, 1 gives us 2. That's how we move. So here we expect 5 terms of this expansion here. Okay, so now what do we do? What do we do here? So when you're looking at binomial expansion, we're expanding here. We have this which we call a term. This is what we call a b term. So when you're expanding, 1 will be increasing in terms of powers, and the other one decreases. So here you can choose. Okay, if they don't specify in the question, but sometimes they will specify to say, for example, maybe expand this one in maybe descending powers of x. So it means x will be decreasing in terms of the powers, then the other one will go out increasing. So now, what do we do? Okay, so since the power here is 4, these are the coefficients which we're supposed to use there. We have 1, 4, 6, 4, 1. Okay, so now in descending powers of x, what do we do? What do we do? This is the easiest this is what we're supposed to do. So if you don't want to use the Pascal triangle, how do you get the coefficients? How do you get your coefficients? This is how you get the coefficients. You need to make use of this formula here. Power combine the coefficient there, okay, which is r. So for example here, the first coefficient which you get, you say 4 combining 0. 4 combine 0. So on the calculator, there is this symbol here, NCR. This is what we use for combination. So what you do, you press 4, then you go on the calculator, press 4, you go on the calculator, you press this sign there, it will bring C, then you put 0, okay? You get coefficient of what? 1. That's the one from the Pascal triangle. Then how do we get the next one? You just say 4 combine 1, you get 4. Okay? Then you say 4 combine 3, you get 6. Then here 4 combine 2, sorry. 4 combine 2, you get 6. Then 4 combine 3, you get 4. Then 4 combine 4, you get 1. So this is how you get the coefficients without using a Pascal triangle. Okay, so now since we know the coefficients which we have there, so now let us try to expand. Let us try to expand this binomial expression in descending powers of x. So now what do? Simple. So get the first coefficient, which is 1. So we'll get 1, that is our first coefficient. Okay, so 1, then I'll come to x. You get x. Since we want x will be decreasing, so it is the one which will have the highest power, in this case 4. So you put 4 here, then y will have what? 0. Okay? Plus, you go to the next coefficient there, which is 4. So you say 4x. So from 4 it will decrease to 3. Then y will increase from 0 to 1. Okay? And when you add the powers on each term, you should get the highest power there in the expression. So for example here, 4 plus 0, you get 4. 3 plus 1, you get what? 4. Let's move to the next coefficient, in this case 6. So you say 6 x to the power from 3 to decrease to 2. Then y will increase from 1 to 2 plus. Okay, the next coefficient is 4. Okay, so x will decrease from 2 to 1, then y will increase from 2 to 3, plus the last coefficient there is 1. So x from 1 it will decrease to 0, then y will increase from 3 to 4. Okay, so what are we saying here? Of course, anything raised to the power 0, the answer is 1. So 1 here times 1, you get 1. Then x to the power 4 is just x to the power 4 plus. Okay? So this is y there. Of course, you get 4y, 4x to the power 3y. Okay? Plus, there you get 6x squared y squared. Okay? Plus, here you get 4xy to the power 3 plus, there you get, of course, x to the power 0 is 1. 1 times 1 times y to the power 4 is just y to the power 4. So this is the general expansion of this expression. Look at this. X to the power 4, x to the power 3, x to the power 2, x to the power 1. Of course, here we have x to the power 0. So when there's this condition here in descending powers of x, so x should be decreasing, then y will be what? Increasing. So this is the general expansion. Okay? So now we know the general expansion. We now know the general expansion. So these are some of the questions which they will ask in an exam. So since we know the general expansion, okay, so we use the same example. We use the same example, but of course we'll get more questions from past papers. So let's say in this question here, okay, let's say in this question here, they have asked us to find maybe without expanding this one. Here we have 1, 2, 3, 4. Okay, let's try to find the fourth term without expanding this one. Okay, so find the fourth term in the expansion. In the expansion of x plus y raised to the power 4. Okay, so now let's try to find the fourth term there. Okay, so we don't need to expand. Okay, we don't need to expand. So before we do anything there, I want you to know this formula. You need to know it. We'll be using it in most of the cases. So n combined r, okay, times a n minus r times b to the power r. This formula here is very important. Okay, that formula there is very important. Okay, so now in this case we want to find the fourth term in this expansion. When they ask in an exam, please, you don't have to expand like what we did in the first place. This is what you do. First of all, here, since we already know the power, n there is 4. Okay, but we don't know r. We don't know r. Now, how do we find this r? Remember what I said? Always a term will increase by 1. So it means term is equal to r plus 1. Okay, anytime you expand, that term will increase by 1. So again, let me introduce you to this formula again, which you need to know. So in this case, since we know this formula here, okay, it can help us to know the r in this case. Okay, so since we want to find the fourth term, so while there is t, we'll put what? R. When you want to find the r, always you need to say, oh, r is equal to t minus 1. Okay, so in this case, r is equal to, what is our t? T is the fourth term which we want. So we'll put 4 minus 1. So r is equal to 3. Okay, since we know r, okay, we can come back now in this formula and substitute. So what we are going to do, let us write the expression which we are using. So we are using x plus y raised to the power 4. So in this case, n is the power which is 4. Then a is the first term. In this case, we're saying that a is equal to x. Then b is this second term. In this case, which is y. Okay. So now we can come here and substitute. So what are we saying here? This is now n is the power. So we'll say 4 combine 3, because we know 3 is the 3 is the R in this case, times A. What is A? A is X. So we say, oh, X raised to the power, in this case, 4 minus 4 minus 3, which is R, times B is Y. So Y to the power R, which is just what? 3. So when you punch on the calculator, 4 combined 3. 4 combined 3, you get what? 4. So this one will give us 4, okay, times X. 4 minus 3 is just 1 there, times Y to the power 3. So when you attach everything, you get 4xy to the power 3. So this is the fourth term. So you don't need to expand. And when you compare what we are getting here and what we got at first are the same. Okay? So this is what you do, okay, to find the position of the term in the binomial expansion. You don't have to expand everything, but first you need to find the R and make use of this formula here. Hey, we're just using the same example. Since we know how to find the position of the term, so now let us find now the middle term. Let us now find the middle term. So we know from this expansion, when you check, we have 1, 2, 3, 4, 5 terms. So here, 2 terms, 2 terms. The middle term is this one again. Again, to find the middle term, you don't need to expand. So again, what do we do? What do we do? So let's do this. Find it. Let me just erase everything then. So find the middle term. Find the middle term. Oh, it's right there. Find the middle term in the expansion of that one. Now, always, they won't ask you to find the middle term when the power there is even. Okay? Only when the power is even, that's when they won't ask you to find the middle term. Because, let's say when the power is 3, when you expand this one, since when the power is 3 there, we'll get 4 terms. So 1, 2, 3, 4, you can't have a middle term there. Okay? So they won't ask you to find the middle term when the power is even, because when you expand an even power, you get an odd terms. Okay? So let's find the middle term there in that expansion. So what do we do? So here, again, we make use of this formula here. N combine R times A to the power N minus R times B to the power R. So here, how do you find the R? Since you want the middle term, so R is found by N being divided by what? 2. So this is how you find R. Okay, when you are taught to, or you are asked to look for the middle term. Okay, so in this case, what will be our R? So R will be equal to, what is the power there? The power is 4 divided by 2. So you find that R is equal to 2. Since we know R, we can come back here in that formula and substitute. So what are we doing here? What are we doing here? N is the power. So we are saying that 4 combined 2 times A, which is the first term, in this case X, so that is the X raised to the power 4 minus what? Minus 2. Then here Y to the power what? To the power 4. So when you punch on the calculator, okay, when you punch on the calculator, 4 combined 2. 4 combined 2, you get 6. Okay? 4 combined 2, you get what? 6. Okay? So this is 6. Okay? 2 minus 4 minus 2, you get 2. Then here Y to the power 2. So this is the middle term without expanding, and that's what we got here. Okay? So this is how you find the middle term without expanding the whole expression there. Okay? So we know how to find the position of the term, general expansion in the middle term. Let's move to the next concept. So, general expansion, medium term, and position of the term we now know. So, they will ask you again, they can ask you, let's move to how we can find the independent term. Independent term, okay? So an independent term, for example, let's say we have this expression here. We get this from a past paper question. Okay, let's get this from a past paper question. The better. So let's say we have sorry, I didn't get this one. I didn't write it. Thank you. So, independent term. So, for example, here we have find. More questions will be uploaded. Find the term independent of x in the expression, rather in the expansion of 3x plus 1 over x raised to the power 10. So let us try to find the term independent of what? X. So meaning the term which doesn't have x. Now you don't have to imagine the work you would have to do there. You expand this one since it has a power of 10. So meaning you need to get 11 terms. Then now you choose which one doesn't have x there. You don't have to do that. So what we are going to do here is this. Okay? What we are going to do is this. So here, this is binomial expansion because we have two terms separated by what? Plus and raised to the power 10. So this is the first term which we call a. The whole of this, don't just get x, you get the whole of that. You get it together with the sign that there was minus, you would have gotten one. So this is b here. So now what are we going to do? Again, let's go back to that formula there. N combine r times n minus r times b to the power r. Okay, that formula is very important. So now what are we going to do here? Before we do anything, we are going to substitute these expressions. So what are we going to do? What is n here? N is 10. So we'll say, oh, 10 combine what? R, which we don't know yet, times a is the whole of this term. So you say 3x raised to the power n is 10 minus r, okay? Times b is 1 over x raised to the power r there. Now you need to know that this power, in this case r, is on both 1 and what? X. Okay? So now, what do we do here? Since here we don't have power, if we had the power here, we would have multiplied. What is that? Since here we have the power of 1, 1 times this one, you get the same thing. Even here we have 1 times that one, you get that same thing there. So, what do we do now to find the r? So to find the r, you need to compare the powers of a and b. So this is a. So what is its power? The power here is let me do it somewhere here. The power, so compare the powers of A to the powers of what? B. So the power of A here is 10 minus R. So comparing, we are equating in short. So this should be equal to the powers of B is just what? R. Okay, so this is 10, okay, will be equal to, when the R goes the last side, you get R plus what? R. So this is 10 is equal to 2R. Okay, since we want the value of R, you can divide 2 both sides. So this one and that one both. So 5 is equal to what? R. So R is equal to 5. Since we know the value of R, okay, we can come back here and substitute. So this is what we get. So this is 10 combined 5. We now know R times 3x raised to the power, okay, 10 minus R, which is 5 times, okay, this is 1 over 3x to the power 5. Okay, so what is now?
Is it not 1 over x?
Oh, 1 over x, thank you. 1 over x, just 1 over x, thank you very much. Okay. So 1 over x. So now what do we do? 5 combined, or 10 combined, 10 combined 5, can punch on the calculator. So 10 So let me show you. Okay, so what we are going to do here is this. You can even use, don't have a calculator with me, so you can solve this one without using a calculator. So what are we going to do? So this is, since here we have 10, okay? So, okay, let me do this, 5 here, okay? So let's say 5 factorial. So 5 factorial is same as 5 times 4 times 3 times 2 times 1. Then here I'll take this one to 10 times 9 times 8 times 7 times 6. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yeah. So now we can reduce something here. We can reduce something here. So this time, this, of course, this is for that one that is factorial. This is 6, okay? 6, okay, 5 factorial will go. Or let me just use a calculator. I don't want you to get confused. So 10 combined 5, 10 combined 5 is giving us 252. 252 times, okay? So this is 3x raised to the power 10 minus 5 is 5, okay? Times, okay, this power is on both 1 and x, so this is same as 1 to the power 5 over x to the power 5 there. So this is 252 times, okay? Bear in mind to say this power is on both 3 as well as what? X. So what are we saying? What is now 3 to the power 5? So 3 to the power 5 is giving us 243. So this is 243, then x to the power 5 times, okay? This is times here, 1 to the power 5 is 1 over x to the power 5. So you can see that since we are multiplying this x to the power 5 and x to the power 5, we will cancel there. Okay, then now you remain with 252 times 243 times 1. That is the term which will be independent of what? x. So 252 times 243 times 1, we are getting 61,236. Okay, so this is the term which is independent of x. Now when they ask you the position of this term, you don't have to worry. Okay, you don't have to worry, since r here was 5. Okay, so now that term is increased by 1. So the position of this one is just the sixth term. Okay, so this term here is sixth term, and that's the term which is independent of x. So by doing that, we have found the term without the value of x, or in short, without x as its variable. So it ends here for the term independent of x. Thank you. Subscribe.